I welcome everyone to this FDP on charging infrastructure. Okay. Mostly we'll be following some rule books and some guidelines that are generally used for development of this infrastructure. Okay. And for maintaining and sustainability of this infrastructure. Okay.
So you went on mute if you're trying to say something.
Hello, am I audible? Hello, Suchi, can you switch on the annotations or the annotations are not available?
Just give me a moment.
Okay. Okay, no problem. So, welcome everyone to this, you can say, uh, session on charging infrastructure. Okay. So, first we will get an overview of what is charging infrastructure. Okay. That is, electric vehicle can be charged in a variety of way depending on location and requirements. Accordingly, charging infrastructure for EVs is of different types and designed for different applications. So, generally, charging infrastructure denotes that your EVs, your charging stations, then your grids that will be supplying the, you can say, uh, uh, power or energy to the stations, and then the generators, those will be generating those energy. So this is a complete infrastructure that has to be taken care of. We now see that the petrol rates are hiking. Yes, obviously. So the demand of EVs will rise. Okay, 2030 was the target. So it will get a peak. So when we get a peak, obviously our energy demands will increase. Okay, because fuel was naturally being produced. Okay, so we don't we just need some energy for extraction. Okay, but now we have to heavily dependent. We will be heavily dependent on our, you can say, energy grids for charging the vehicle when the demands will increase. Okay. Charging infrastructure is a, like, the most important component of the infrastructure is the electric vehicle supply equipments. Okay. The equipments that are used for, you can say, supplying, like, the charging station, okay, the charge and plug, okay, then your grids, then smart grids, or you can say even the vehicle will also be able to send their charge to the grids. Okay. So these are the things that are used in your electric vehicle, or you can say charging infrastructure. Okay. So electric vehicle supply equipments, what is electric vehicle supply equipments? We can see that these are the, we can say, chargers. Okay. And the charging station. You can have different types of charging stations. Okay. For different kinds of vehicles, like you'll be having two-wheelers, three-wheelers, e-car. Okay. Then first generation cars, second generation cars. Okay. And how you will be connecting those vehicles to the infrastructure. Okay. Then charging methods can be AC supply, can be DC supply. Okay. Charging methods can be AC supply, can be DC supply. Mostly DC supply is being used. Okay. AC is used for running the charging station. Okay. And DC is being used for providing the charge to the vehicle. Okay. Then what are the charging range that you generally need? Like for your power level, that is P should be less than or equal to 7 kilowatt. Okay, that is power consumption should be less than or equal to 7 kilowatt for E two-wheelers, three-wheelers, e-car and other LCV, light commercial vehicles. then it can go up to 22 kilowatt, 50 kilowatt chargers, okay, for e-cars, LCVs, and medium commercial vehicles. Okay. Then power ratings. EVs have different power ratings on levels based on charging requirement, which in turn determines the input power requirement for charging infrastructure. Okay. You can see that this table 2 categorizes this. Okay. What are the requirement of different charging infrastructure? Okay. What is the requirement of charging infrastructure? Generally, for e-cars, we'll be having 30 to 80 kilowatt per hour. Okay. This much will be the requirement. So now, battery swapping is also another technology that is generally used for, you can say, like in your e-rickshaws, in your e-bikes, or in your e-cars, you can use the charging. Okay, you can swap the batteries. Okay, for, you can say, getting new. Like if you want to, uh, like don't want to have a fixed size. Okay, in your cell. Okay, you don't want to have a fixed size of capacity. Like I will buy it with a minimum capacity of 5 kilowatt hour. Okay, then I can swap more batteries, or I can add more batteries to get more power. Okay, I'll be using 5 kilowatt hour, then I can increase it to 10 kilowatt. Okay, and 20 kilowatt hour. Okay, so battery swapping, manual swapping, and autonomous swapping. Okay. Manual swapping generally is done, you can say your vehicles will manually swap it, or it will automatically swap it. Okay. Then you can say battery swapping advantages. Okay. Generally, EV charging is completed in minutes. Okay. Barriers, lack of standardization among EV batteries. Batteries can be charged away from swapping points, allowing more freedoms in setting up swapping facilities. Unsuitable battery pack designs to enable ease of swapping, weight dimension, and ergonomics. Okay. Reduction in upfront cost of EVs as battery ownership is replaced by battery leasing. Okay. And increased predictability of battery life due to controlled charging conditions. So these are the advantages that you will be having if you are using a battery swapping technology. Barriers, lack of standardization among EV batteries, unsuitable battery pack design to enable ease of swapping. Okay. Like different types of vehicles, you will see that small YOLO vehicles are there. Okay. Big size bikes are there. Okay. So different types of size or different size of batteries has to be included. Greater number of batteries needed to power same number of EVs. Shorter commercial life of battery packs due to customer preference for new batteries with higher range. Slower adoption of charging methods by OEMs. Higher cost of battery leasing over the life of the EV. Okay. Higher GST on separate battery versus battery sold with EVs. Okay. At present, the battery swapping is considered feasible, okay, and it is being implemented also in Bangalore and other areas. We can see that battery technologies or battery swappings are being completely, or they are implemented. Okay. Okay. Then EV charging standards for interoperability. Like if you have we have different manufacturers of different EVs. Tata is there, Mahindra is there, MG is there. In two-wheelers, Ather is there, Ola is there, your TVS is there, okay, your Hero is there. Now all they should match with each other. Standards has to be there, or else you have to put one charging station for this vehicle, another for this. So you'll be having, like, you should, it will be a very heavy load on the manufacturers or also on the station engineers, those who, you can say, those who generally is, you can say, install the stations.
Sorry, you're on mute.
Okay. So standards ensures in interoperability and compatibility as of EVSE with all EVs. The Bureaus of Indian Standard, the National Standard Body of India, is responsible for formulating EV charging standards for the country. BI is a member of International Electrotechnical Commission, which is a global body that is developing reference standards to ensure interoperability and minimize trade barriers for electric vehicles. As I said now, that is we should have standardized sockets for all vehicles. Okay, that is what is needed the most. Okay, that is standardized sockets. These are the standard sockets that are used for recharging your, sorry, charging your batteries. You will see if you go for your Ether, okay, you have this socket. Ola has this socket. Vita has a different socket. Okay, so that generally causes we as users we know the problem that or wherever there is a charging station and there is a charging plug for two-wheelers, our vehicle should be able to charge. Okay. Charging plugs, this is for cars. Okay, the charging plug is used for cars. Okay. So from charging stations to charging points. Generally, charging stations refers to high power electric vehicle supply equipment. Okay, remember your charging station, as I have said, is also a part of your electric vehicle supply equipment. Okay, typically mode 3 or mode 4 charging, often with multiple charging guns. Okay, that means it can have one or two or more than that. Okay, charging plugs that can be accessed as a portable charging cable. While the initial deployment of charging infrastructure in India focused on charging stations, it is increasingly evident that most public charging needs can be served by a densely distributed network of charging points. Okay. So box, you can say a public charging point in the EU, normal charging point comprises the major share of all charging points among European countries by the end of 2019. This is old data. Okay. It should have increased. So we are seeing you can say 11 to 22 kilowatt of consumption in, sorry, that is your, most of the consumption is 11 to 22 kilowatt, then 3 to 7. So these are two-wheelers and your three-wheelers. Okay. Then 50 kilowatt is like uh, bigger size MCVs. Okay. And 50 to 100 kilowatts are for your, those are for industrial applications. Over 100 kilowatt are for industrial applications. So an EV charging network comprise many normal power charging points is preferable with one with limited high power charging station. So that is, you can have two or three normal power charging stations, okay, with limited high power charging stations. For EVs, any parking location where the vehicle is stationary and which has access to EV charging point can be an opportunity to recharge the vehicle battery. Wherever you get a charger, okay, like there should not be any kind of anxiety, range anxiety should not be there. Okay. Whenever you can suggest like your petrol stations, you can get petrol stations anywhere. Okay. And you can fill up your petrol stations. Mostly for urban areas. This is we are looking at the urban areas. Okay. This approach to charging infrastructure implements promotes a distributed network of EV charging points for users to plug into various locations at residence, apartment building, offices, campuses, malls, other areas. The use of normal power charging. A dense network of normal power EV charging points reduces the need for high power and ultra high power charging points, which are more expensive and can be detrimental to EV battery health if overused. Okay. Then cost efficiency of charging infrastructures. Normal power charging points are not only less expensive but are also require less electricity and less space, which further reduces capital costs. They can be connected to low voltage single and three-phase distribution network, which are widely available in building and public spaces. Okay. Lowering the upfront cost of setting up charging infrastructure reduces the need for government subsidies and improve the visibility of private sectors participating in charging infrastructure. Like not only government should put charging stations, private sectors should also get required subsidies for setting up the infrastructure. Okay. The EV charging ecosystem comprises of multiple components and processes. The provision of land, the supply of electricity for charging, okay, specific installation for EV charging equipment, day-to-day operation and maintenance of EV charging facilities and services, allowing EV owners to use charging facilities. Okay. Okay. This chapter you can say identifies the public and private stakeholder responsible for government of EVs and need for coordination. Okay. So classification of EV charging infrastructure. How can we classify that a specific land, a specific point in map, or you can say specific location can be a good point for charging infrastructure? We know that our previous, where we have the petrol station, if we just put a charging infrastructure at a petrol station, okay, then we know that yes, people will come and they will charge at the petrol station. But problem is like in a petrol station, how much vehicle can be charged? Okay, whether that node is good for that, like it can be scaled or it cannot be scaled because your charging needs time. Okay, and in a day, you can like if the people little bit get good amount of charging station, they will start, I can say they will not be charging like the timings of people will change. Okay. They want to have a fast charge or a quick charge stations where they will be charging and they will be using. Okay. So those kinds of habits when it will increase. So the location should be scalable. Okay. You can say more amount of vehicles can be added in later time. Those things has to be taken care of while selecting the specific location. Okay. The governance of EV charging infrastructure depends on its ownership, use. Broadly, EV charging infrastructure can be classified as public, semi-public, and private. Okay. So private charging uses dedicated charging for personal EV or EV fleet owned by one entity. Like someone will install a charge. It is for his own consumption. Location, independent homes, dedicated parking spots in apartment offices or fleet, any location with land availability. Ownership, individual EV owners, EV fleet owners, and operators. Okay. Then self-operated or CPO managed. Then semi-public charging, shared charging for a restricted set of EV users. Apartment complexes, offices, campuses, gates, communities, shopping malls, hospitals, all these are semi-public charging. Ownership, host properties, like the apartment will own all the charging equipments. Okay. Mostly the charging equipments it will own. Okay. Land maybe his own land or shared land. They will own this. That is semi-public charging. Okay. Okay. This is your semi-public charging. Okay. Like P1, that is your personal charging, then semi-public charging is there. Then you can have your public charging. Okay. Public charging open for all EV users. That is, it will be open. Like this will be like a dedicated charging station. Okay. A dedicated charging station for charging different kinds of EVs. Public parking lots, on-street parking, charging plazas, okay, petrol pumps, highways, metro stations, municipal authorities, PSU, CPO, host properties, CPO managed, all these things. Okay. These are not fixed categories and some charging facilities may demonstrate hybrid characteristics. For instance, charging infrastructure owned by EV fleet owners, operators for captive use is considered private. Okay. That means uh, it will only be used by a public, okay, as a paid servicing only. It will not be like a fleet, mostly like three or four same type of vehicle can get charged, okay. But mostly those will not be the fleet owners will have a different license for charging these things. So, roles and responsibilities of government stakeholders. Many government bodies at the center, state, and local levels are responsible for governments of EV charging. The role played by these bodies can be categorized as policy making and regulatory functions and executive or implementing functions. So, the government bodies, like the private bodies, there should be a tie-up between the private bodies and the government bodies. If you want to have different like selection of land, okay, then selection of which grid to use, all these things will depends on Ministry of Power, okay, Ministry of Housing, Ministry of Development, okay, your nearby development authorities, they will be needing you to, they will be helping you to set up the grids. Okay. Executives or implementing authorities, Bureau of Energy Efficiency, Department of Heavy Industry, these are the DISCOM, these are the, you can say, these are the ones that will help you to install it, okay, on your premises. Okay. Transport authority, like where the, remember, this is where the private owner wants to use. The government and private. The government private owner can also say that, okay, I will share with the government. Okay, I will be like, I will be having 15 charging stations in a metropolitan, or you can say metropolitan transport authority or metropolitan region. Okay. So the private and the government owner will, as you can say, government will tie up to get to have a charging infrastructure. This will be helpful. This will be much faster because if only government is going to do this, then it will be slow. But just like your petrol pumps, how petrol pumps, how we have so much amount of petrol pumps because both private owners and government owners, like we can say there will be a tie up between the government and some other like our Indian Army. Okay, so they will be getting some petrol pumps, and private owners can also own petrol pumps. They will be having very good margins. Okay, they will be given very good margins. Okay, so state nodal agencies, DISCOM, Urban Development Authority, Transport Department. Okay, State Transport Acknowledgement, Metro Rails Corporation, other things has to be taken. Working group for public EV charging infrastructure. Multiple state and local government bodies are responsible for successful rollout of public charging infrastructure. However, at present there is no mechanism for cooperation between the different agencies. Okay. So this actually this is increasing. Okay. This is increasing with time. Like there will be cooperation. We are seeing a good amount of charging infrastructure within urban areas and within a certain point. Okay. And apps, connectivity is coming. Okay. Your route planning is coming. That will help you to set where the charging has to be done. Okay. Maintenance is coming. All this AI powered route planning, AI powered maintenance, AI powered, you can say your, uh, you can say system. Okay. So that will be more efficient. You can properly plan where to charge, how much distance you will move. Okay. You can do these things very well. Okay. Mostly this is for MCVs. Passenger vehicles are very well organized within the urban sectors, okay, or urban areas, because in urban areas, good amount of charging stations are there. But when you try to transport something from one point to another using, we can say, certain regions where setting of infrastructure is not good, then planning apps, okay, planning agents will be helpful for you. Okay. So functions of working group. So these are some of the, you can say, work group related, like you can uh, have a, okay, just okay. Let's see this. Okay, we'll get the, that is, what are the types of authorities that we have to go through? Okay, this is of one state. So how can we implement them? Okay, based on, like we have to go for national level and state level authorities to set up our, we can say, charging infrastructure. Okay, and again, so that, okay. So, Ministry of Power, Ministry of Housing, Bureau of Indian Standards, BIS for certifications. Okay, remember, Ministry of Power will help you to set how much usage will be there, how Housing Affairs will give you land, BIS will be for standardization where good products are using, road and highway transport will help you, like a certification from there, Electric Authority, Ministry of Heavy Industries, Niti Aayog, okay, Department of Science and Technology, all these things has to satisfy. Okay. You can very easily apply this on the Niti Aayog, can say, website. Okay. So we'll move to charging point operators and e-mobility service providers. Okay. So charging point operators, CPOs, okay, and e-mobility service providers manage and enable day-to-day operations of EV charging infrastructure for semi-public and public charging facilities. CPO and EMSPs are also responsible for setting up the framework architecture, protocol, and process to enable centralized management of charging facilities and their communication with DISCOM and ensure efficient access to EV charging services for consumers. Charging point operators set up, manage, and operate a network of EV charging points for semi-public or public uses. They may own the EV charger or may operate the charger on behalf of charging point owners. CPO cater to different arrangements and can simultaneously manage a mix of client-owned and self-owned charging point networks. So, mostly, you can say vehicle and through any EMSP. That is, you can say your electric mobile service point. Okay, that means you will get like a app where you can select your charging station and you can also scan the QR on the charging station. Okay, to for payment or for connection. Okay, the main responsibilities of a CPO charging, you can say mostly your charging point operators. Okay, and access space and power requirements for charging at each site. Okay, via availability to design optimal charging installations, coordinate with nodal and executing authority to get the required permission, connection, approval, and certification. Okay. Then you have your installation and commissioning of all those things. Okay. Operation and billing. So mostly to go for operation and billing, we have to know about two things. What is that? That is active charging and passive charging. Okay. So what is active charging? Active charging means continuously the price of the charging infrastructure changes.